Very good afternoon to all and one and all. We are in the last phase of first unit. Okay, that is nothing but our branching instruction we have covered in the yesterday last lecture, and today we are going to cover some control instructions. Okay, so there are three branching instructions. What is the use of branching instruction? Whenever there is a concept of subroutine. Okay, so when there is a when we want to execute the subroutine, we have to go towards the branching instruction. Now, what is the subroutine? It is a part, or it is not a part of main program, but it is frequently required in the main program. Okay, so there are basically three branching instructions are there. One is a jump, second is a call. Whenever call is there, it always ended with return, and last one is a restart. These three instructions are come under the category of branching instruction. Why? Because these three instructions going to change the sequence of program execution. Okay, now these three instructions are called means jump and call are of two types: conditional jump and unconditional. Okay, so in unconditional it will directly perform the specific specific task. If there is a jump, it will, without any checking of the condition, it will directly jump. If it is a call, without any checking for the particular condition of flag, it will directly call the subroutine. Okay, when it is a unconditional. Okay, now when there is a when you are going to use a conditional branch instructions, in that case, to perform the specific task like jump or like call, firstly you have to check the status of flags. Okay, that is called as a conditions of different flags. Now if that particular condition is satisfied, then and then only it will perform the specific operation like jump or call. If that condition is not satisfied, then it will execute next instruction, okay, which is in the main program. Now see, as there is a four flags is going to be used for the conditions. So four flag, and it's a yes or no condition. So in short, you are having total 8 conditions to check. Okay, so these are these 8 conditions. Okay, these are for the jump and these are for the call. Okay, last one is a restart. Restart is also the one type of branching instruction which will change the execution sequence. Whenever you put restart rst 0, your execution again starts from 000 location. If you put rst 3, then your execution going to be start from 0018 location. Okay, in this manner you can change the execution sequence. It is not one after the another. Okay, so it will in the branching instruction, PC does not maintain the sequence of execution. So the sequence of execution is going to be changed, and that's why it is called as a branch. Okay, and we are in the now last phase, that is the control instructions. So what is the use of control instruction? To perform various controlling operations. Now first control instruction is NOP. NOP stands for no operation. NO means no, OP means operation. कोणतंही ऑपरेशन या instruction मध्ये केलं जात नाही. So no operation is performed. The instruction is fetched and decoded, but no operation is executed. Now, is there anyone who can tell me the use of this NOP? तुम्हाला काय वाटतंय? If we are at all not going to perform any operation, then what is the use of this instruction? Why we need to use this instruction? Any idea? Whatever the up till now, whatever the instruction we have seen, each instruction is going to perform some specific task. NOP is the instruction under which no any specific task is going to be performed, not a single one. Okay, then why we need to waste the time on this instruction? तुम्हाला काय वाटतं? विचार करा बरं. Is it a wastage of time? See, take the look of third line. The instruction is fetch and decoded. Means what? You have to read the instruction. Fetch means घेणे. So you have to take it from the basis. You have to decode that instruction. Means whatever the time you are required for this, it is of wastage. No. Why? Because after doing that much operation, it will not going to perform any operation. Then what is its use then? NOP. Now, if consider that 1 second is required for fetch operation and for example 3 seconds are required for decode operation, in total you are having 3 seconds, 4 seconds, sorry, this 1 second and 3 seconds for decoding. Means 4 seconds you have done all these things, and after the, what is the output at after 4 seconds? Nothing. Why? Because this instruction is not going to perform any operation. Now you tell me whether it is feasible to use this instruction. It is just a wastage of time. Then why?
For delay,
Yes? Yes?
for delay, we can use this
Very
operation.
good. Very good. That is exactly the answer expected from you. See here. What happens? For example, before the instruction, whatever is your status, same status is going to be observed after this instruction. But see here, what operation you are going to do? You have to make first fetching. What is meant by fetching? You have to take the instruction from the buses. Okay, well, when the user writes some instruction in the program, it will transferred by the buses towards the CPU or your ALU, for example. Now on that buses your instruction is there. Instruction is made up of two parts, opcode and operand. Out of that means entire instruction, opcode is fetch. Fetch म्हणजे घेणे, बसेस कडून तो घेतला जातो. Who will take that opcode? Instruction register, which we have seen in the architecture part. Okay, that instruction register gives that opcode towards the decoder. Now after receiving that opcode, decoder decodes. Means what? In short, it will take some time. Okay, after decoding it will not going to perform any operation, but whatever the time required for fetching and decoded, that time you will get as a delay. Isn't it? So NOP is a very important. Whenever you want some delay, you can directly write NOP. Consider kara fetch means to execute the fetch we need 1 second, and to decode the means to decode that instruction you need that 3 seconds. In short, you are getting 4, you are wasted here 4 seconds. Means during that 4 seconds no any particular operation is going to be performed. आता एकही ऑपरेशन होत नाही. याचा अर्थ काय? Whatever the status of memory, whatever the status of registers remain as it is. Why? Because no operation is going to be performed, so no any updation. Flag register is not going to updated. Why? Because no operation is there. Okay, so whatever the status previous to the execution of NOP, same status is going to be followed after the execution of NOP. मग तुम्ही म्हणणार मॅडम याच्यात मध्ये काय झालं, तर इथं जो काही 4 सेकंड होता तो 4 सेकंड तुमचा डिले झाला आउटपुट यायला. समजतंय? सो वेन एव्हर यू वॉन्ट डिले यू हॅव टू यूज द NOP. मग तुम्ही म्हणाल मॅडम आम्हाला 8 सेकंड डिले हवाय. मग इन दॅट 8 सेकंड तुम्हाला काय करावं लागेल? यू हॅव टू यूज NOP 2 टाइम्स. बिकॉज फॉर एक्झाम्पल मग हे 4 सेकंद देतं का? नाही. मी तुम्हाला समजायसाठी एक नॉर्मल एक्झाम्पल घेतलंय. याचे जे काही डिलेज असतात ते मिली सेकंड मध्ये असतात. ओके, सो आता कन्सिडर करा की तुम्हाला जास्त डिले पाहिजे, देन यू कॅन यूज NOP 2 टाइम्स. If you want further more delay, you can use NOP 3 times. You can use NOP 5 times. समजते? Depending upon your requirement, you can use this one. Okay. Now, पहिली आता एक गोष्ट लक्षात घ्यायची इथे, डिले तुम्ही NOP यूज करून पण करू शकता, पण आपल्याला जे डिले यूज करायचे ते नॉर्मली आपण टायमर यूज करून करतो. याच्यासाठी म्हणजे आता जेव्हा आपण कंट्रोलरचे प्रोग्राम घेऊ तेव्हा तुम्हाला यू कॅन गेट क्लिअर आयडिया ऑन धिस. ओके, एव्हरी टाइम यू टू जनरेट द डिले NOP इज नॉट गोइंग टू बी प्रेफर. याला 2 रिझन्स आहेत. पहिलं रिझन म्हणजे बघा, जर एका NOP साठी फॉर एक्झाम्पल 4 सेकंड मिली सेकंड लागत असतील तर तुम्ही जे जनरेट करणारे डिले तर ते तुम्ही 4च्या मल्टिपल मध्ये जनरेट करू शकता. म्हणजे जर एक NOP यूज केलं 4 मिली सेकंड मिळेल, 2 NOP यूज केलं 8 मिली सेकंड डिले मिळेल. समजतंय? मग आता जर फॉर एक्झाम्पल तुम्हाला 6 मिली सेकंड डिले हवाय, वेदर यू कॅन जनरेट विथ द NOP? नो. का? आयदर NOP तुम्ही एकदा यूज करू शकता किंवा प्रोग्राम मध्ये सेकंड टाइम यूज करू शकता, थर्ड. म्हणजे जर एका NOPचा 4 असेल तर तो 4च्या मल्टिपल मध्येच डिले देईल. मग तुम्हाला जे इन बिटवीन डिलेज असतात ते इथं तुम्हाला जनरेट करता येत नाहीत बाय युझिंग NOP. मग जे की पॉसिबल आहे कुठे? टायमर्स मध्ये. सो बाय युझिंग द टायमर मोड, TMOD रजिस्टर अँड TCON रजिस्टर, वी ऑल्सो जनरेट द delay. Okay, and that delay is a standard delay. Why? Because depending upon your time requirement you can change its value. Here you cannot change value of the delay. Why? It is always gives the multiplication in terms of multiple of 1 delay. हे कळालं का सांगा बरं? Yes or no? रिप्लाय द्या, कळालं तर यस म्हणा, नसेल तर नाही. फास्ट.
Repeat, madam.
Okay, see, by using NOP you can generate a basic delay, but if you want a specific delay, for example 6 millisecond or for example 10 millisecond, then by using the NOP it is not possible to generate a specific delay. Okay, so for that case NOP is not going to be used. मग त्या डिले साठी काय यूज केलं जातं, टायमर्स आर यूज फॉर दॅट स्पेसिफिक डिले. ओके, आता NOP फॉर एक्झाम्पल 1 millisecond आपण for 4 बघत होतो. If NOP takes 4 millisecond and if you want to generate a 8 millisecond delay, then what you have to do? If one NOP gives the millisecond 4 millisecond delay and you need a 8 millisecond delay, what you have to do? एक NOP 4 मिलीसेकंड डिले जनरेट करतो. तुम्हाला जर 8 मिलीसेकंड डिले जनरेट करायचा असेल तर तुम्ही काय करताल? 2 NOP, दोनदा NOP यूज करणार. ओके, गुड. But if you want to generate a 6 millisecond, then it is not possible. In that case, you have to go towards the timer. So at this stage, only remember that what is the use of NOP instruction to generate a delay. Okay, so see, first control instruction is NOP. NOP stands for no operation. Means what? Means after execution of this instruction, no operation is going to be performed. Only fetching is there, instruction is decoded, but no any operation is executed. Okay, then what is its use? To generate a delay. Next one is a halt, HLT. HLT is a symbol, but how you can read it? It as a halt. Halt means stop. Now see here. The CPU finishes executing the current instruction and halt any further execution. Means what? Whenever you write any program, it will always end with the HLT. Okay. After once CPU get reached to the HLT, it will not execute any further instructions. Means what? Your program is in halt. Halt means बंद होणे किंवा stop होणे. पण रिसेट म्हणजे कम्प्युटर बंद होणे. हॉल्ट मीन्स काय? प्रोग्रामचं एक्झिक्युशन तिथं संपणं. समजते? सो वेन एव्हर यू राईट एनी प्रोग्राम, युअर प्रोग्राम गेट्स always end with HLT instruction. Okay, so see here, HLT stands for halt. The CPU finishes executing the current instruction and halt any further execution. Halt means बंद करतो, पुढचं एक्झिक्युशन तो तिथे बंद करतो. फॉर एक्झाम्पल, you have written 10 lines program and 5th line is your halt. Then after 5th line it will not going to use from 6th line onward it will not execute any instruction. Why? Because at 5th line you return HLT. Means what? You have instruct the PC that you have to stop now or you have to finish your execution now. Okay, so always halt is ended with, means always halt is present at the end of your program. Okay, now see, an interrupt or reset is necessary to exit from the halt state. Now once the program is completely executed and your last instruction is halt, so your PC is not going for the further execution. Now if you are interested in the further execution, either you have to generate one interrupt or you have to reset your program. Okay, reset your PC so that it will again execute from the fresh. Okay, so HLT is used to stop the program execution. सो आपण कधी थांबवतो? जेव्हा आपलं पूर्ण एक्झिक्युशन झालं असेल तेव्हा. दॅट्स वाय युअर प्रोग्राम ऑलवेज एंडेड विथ द HLT. HLT नॉट ऑलवेज इन बिटवीन द टू प्रोग्राम्स. ओके, नाउ नेक्स्ट, that is very important part, ream. Okay, there are always question is going to be asked on the ream or either on seam. Now see here, R for read, I for interrupt, M for mask. Okay, so ream stands for read, interrupt, mask. Okay, now see here, it is a multi-purpose instruction. Means under this instruction you can perform many tasks. Okay, used to read the status of interrupts, used to serial data input bit. Now कुठले कुठले टास्क करू शकतो? Okay, so ream बद्दल तुम्हाला question, how question can be asked in the exam, that is draw the structure of ream and explain its uses. Okay, now see, this is the ream instruction. Okay, now again ream instruction is going to control over 8 bits, D0 to D7. Each bit is used, each bit is used for the different functions. म्हणजे काय? See here, R means read. अगेन वन्स अगेन आता हे कंटिन्यू करायच्या आधी बघा. सी तुम्ही पुस्तक वाचताय म्हणजे तुम्ही पुस्तक रीड करताय. तुम्ही मला सांगा वेदर यू आर हॅव्हिंग द अथॉरिटी टू चेंज द कंटेंट ऑफ द बुक वेन यू आर रीडिंग द बुक. येस ऑर नो? No. Means what? Whatever the contents are there, you are going to just read it without any change. So first thing you have to remember that with the help of ream instruction, you are not going to change any content. You are just going to acknowledge. Means what? समजून घेताय कोण ऑन आहे कोण ऑन नाहीये. ओके, किंवा काय डेटा आहे ते. बुक वाचताय म्हणजे काय की बुक मध्ये काय डेटा आहे तो फक्त तुम्ही कळवून घेताय ना, की आता फॉर एक्झाम्पल this is the MMC book. So what is in the book you have to just read means you have to just going to acknowledge the content of the book. Okay, similarly with the help of ream instruction you are just going to analyze the content of the or analyze the status. कुणाचा status? Different flags means interrupts चा पहिली गोष्ट. Now see, whenever there is a interrupts comes, there are two possibilities. First thing what? It should be avoided. Okay, might be they should be avoided or might be they should be executed but in the pending mode. Okay, so see, except trap, microprocessor has the authority to cancel the interrupt or to make the interrupt into the wait state. Okay, we have already seen in the interrupt structure there is a one concept that is maskable and non-maskable. What we have seen at that time, trap is the only interrupt which is non-maskable, means unavoidable. So remaining all the interrupts are अवॉइडेबल. ओके, अवॉइड मीन्स व्हॉट? टू स्टेट. आता फॉर एक्झाम्पल आपण परत एकदा तेच बघू की आपलं लेक्चर चालू आहे, क्लासरूम मध्ये तुम्ही आहात आणि फॉर एक्झाम्पल मी तुम्हाला शिकवते आणि कोणतरी एक जण आलं. ओके, दॅट इज नॉट इम्पॉर्टंट की प्रायोरिटी त्याची कमी आहे. ओके, मग मी त्याला दोन गोष्टी म्हणू शकते. फॉर एक्झाम्पल मी काय म्हणू शकते की मी आता तुम्हाला अटेंड करू शकत नाही, तुम्ही जावा. म्हणजे काय, मी कॅन्सल केलं. किंवा मी त्यांना काय म्हणू शकते, माझं लेक्चर 1 तास झाल्यावर तुम्ही या. म्हणजे काय, सेकंड केसमध्ये काय बघा की पेंडिंग ठेवलं मी. समजते? पेंडिंग मीन्स व्हॉट की मी कॅन्सल करत नाहीये पण आता अटेम्प्ट पण करत नाहीये. ओके, आणि दुसरं काय, मास्केबल म्हणजे मी अवॉइडच केलं की मी त्यांना सांगितलं मी काय भेटू शकत नाही, तुम्ही जावा. समजते? सो दोन या केसेस इंटरप्ट सोबत होतात. मग आता बाय युझिंग रीड इन्स्ट्रक्शन यू आर गोइंग टू अनालाइज whether the interrupts is in the pending mode or whether the interrupts are maskable. समजते? Now see here, one by one we have to go to study each bit. Now see here, D0 bit. D0 bit, D1 bit and D2 bits are related to flag interrupt 5.5, 6.5 and 7.5. Is it? Now see, if this bit is 1, what is mean by D0 bit is 1? When this bit is 1, you are going to just read this. Why? Because we are in the ream instruction. In the ream instruction, you are just going to analyze. You are not going to make it 1 or make it 0. That authority is not allowed in the ream instruction. Read means what? Only you have to read that one, whether it is 0 and whether it is 1. Now we are reading means what? We have to make analyze what if it is 0 or what if it is 1. Now see here, if 5.5 bit is 1, what it means? The interrupt is maskable, means what? This interrupt is avoided. Is it? If 6.5 is 1, then what it means? Interrupt mask. That is, that interrupt 6.5 is mask. 7.5 bit is 1, means what? That interrupt is masked. So interrupt masked if bit is 1. If not 1, means if it is 0, then it is not masked. Then it is come under the pending state. Is it? Now see here, if D4 bit is 1, what it means? Interrupt 5.5 is in the pending mode. If this bit is 1, what it means? Interrupt 6.5 is in the pending mode. Pending means what? It is not avoided, but it is not executed yet. It is going to be executed, not executed at this moment. Okay. Now see, next D6 bit. When this bit is 1, what we have come to know? That interrupt 7.5 is in the pending state. Okay, if it is 0, then what it means? It is not in the pending state. If that interrupt is not generated, then for example, interrupt 7.5 is not generated, then this should be 0, this should be 0. If interrupt is not there, then what is the case of whether it is a pending or whether it is executed, is it? So see, next D3, interrupts enable flip-flop. For example means what? If you want to analyze this, means if there is a interrupts, in that case only this IE should be 1. If IE should be 0, then all these 6 cases doesn't matter. Why? Because it will not allow any interrupts to come. IE stands for interrupt enable. Okay, this bit decides whether the interrupt is coming or whether its interrupt is not coming. If it be, this bit should be 0. What it means? Interrupt should not be allowed. Means if this bit should be 0, then there is a no any use of these 3 bits and these 3 bits. If this bit is 1, means what? Interrupts are allowed. Okay, ठीक आहे, interrupts allow आहेत. ना मग कोणते आलेले आहेत किंवा कोणते इंटरप्ट्स आता चालू आहेत, कोणते पेंडिंग आहेत, मग आपण इकडे बघायचं. सी आई म्हणजे काय? इंटरप्ट्सला इनेबल करायचं. जर इंटरप्ट्स चालूच नसेल, इट इज लाईक मेन स्विच ओके इन द होम अँड इट इज लाईक द स्विच ऑफ फॅन. आता तुम्ही कधी बघताल फॅन चालू आहे का नाही हे कधी ठरेल? जर तुमचा मेन स्विच ऑन असेल तर. ओके, समजा तुमचा मेन स्विच बंद आहे तर इट इज नॉट मॅटर की फॅनचा स्विच चालू आहे का बंद आहे का, कारण की बाय डिफॉल्ट तर बंदच असणार का तुमचा मेन स्विच ऑफ आहे. समजते? तसं आई डिसाइडेड्स वेदर द इंटरप्ट्स आर कमिंग ऑर नॉट. ना आता हे पूर्ण जेव्हा आपण बघतो, समजा हे बीट जर 0 असेल तर याचा अर्थ आपल्याला काय कळणार की कोणतेही इंटरप्ट्स इनेबल केलेले नाहीयेत. हे बीट जर 1 असेल, बाय सीइंग दिस बीट ॲज अ 1 की आपल्याला कळतं इंटरप्ट चालू आहेत. ओके, नाव मग आपण हे 3 अनालाइज करून सांगू शकतो की सध्या कोणते मास्क केलेले आहेत. ओके ना, आणि हे 3 सांगू शकतो, हे 3 इंटरप्टचा स्टेटस बघून सांगू शकतो की कोणते पेंडिंग आहेत. समजते का? येस ऑर नो? हॅलो, गिव्ह मी सम रिप्लाय. हॅलो. And last one is a SID. Okay, I will repeat once again. Okay, after SID I will repeat all the 8 bit from D0 to D7. Last one is a SID. SID is the bit which is used to read the serial input data. Okay, whatever the serial inputs are there, you can read from this bit. ओके, नाव तुम्ही म्हणाल मॅडम इनपुट तर मोठं असतं, मग हे एकच बीट आहे. सी, इन द सिरियल इनपुट ॲट अ टाइम यू आर गोइंग टू रिसीव्ह ओनली 1 बीट. व्हॉट इज मीन बाय सिरियल? 1 आफ्टर द अनदर. ओके, दर्शनाची बारी कशी असते विठ्ठलाची? एक झाल्यावर दुसरा येतो. ॲट अ टाइम नंबर ऑफ येत नाहीत. आयदर ॲट अ टाइम एकतर 0 येऊ शकतो किंवा 1 येऊ शकतो. सो दॅट सिरियल इनपुट डेटा यू कॅन रीड फ्रॉम दिस D7 बीट. Once again see that is this is the ream instruction. There is always alternate year there is a question going to be asked in the ream instruction, that is explain the ream instruction with its structure. Now see ream instructions, that is nothing but the read interrupt mask. This gives you the status of different interrupts and serial data. First thing, now see different bits in the ream instruction is going to relate with the different interrupts. Now first thing is a D3 bits. D3 bit is nothing but the interrupt enable bit. Okay, by seeing the status of D3 bit, we can come to know whether interrupts are allowed or not. If this IE bit is 1, then only we can allow the interrupts. Okay, now see, once we get that interrupts are coming, then we can find out whether it is in the pending mode or whether it is in the maskable mode. Okay, now see, by analyzing D0 to D7, we can find out is there any interrupt which is in the maskable mode. Okay, how we can analyze? By seeing its a bit status. If these bits are 1, then what we can say? These interrupts are in the maskable mode. If these bits are 0, then what we can say? There is a no bit for in the maskable mode. Okay, now D4 to D6, by seeing these 3 bits, we can say whether the interrupts are in the pending mode or not. Okay, for example, D6 bit is 1, then what we can say? Interrupt 7.5 is in the pending mode. Okay, D5 bit is 1, then what we can say about that? Interrupt 6.5 is in the pending mode. Means what? That interrupt is not executed yet. And by analyzing D4 bit, what we can say? Interrupt 6.5 is in the, interrupt 5.5 is in the pending mode. Okay, and by seeing the SID bit, you can read the status of input bits. Okay, whether input bits is 0, serial input bits, whether it is a 0 or whether it is a 1. For example, D0, D7 bit is 0, then what we can say? Serial input data is 0. If D7 is a 1, what you can say? Serial input data is 1. Is it okay now? Hello? Hello? Is it okay? Give me reply. Hello? Now see. Rim is used for the following purpose. Now काय rimचा use आहे बघा? To check. काय check करू शकतो तो? Whether RST 7.5, 6.5 and 5.5 are masked or not. Okay? Yeah, by seeing this status of these 3 bits, you can predict about whether these interrupts are masked or not. If these bits are 1, what you can say? These are masked, means avoided. If these bits are 0, then what you can say? These bits are not masked. Okay, means they are going to be executed. Now you have to check for the pending state. Now see, to check whether the interrupts are enabled or not, by seeing the D3 bit you can say whether the interrupts are enabled or not, and by seeing D4 to D6 what you can say to check whether the interrupts are pending or not. If there is any one, then that interrupts are in the pending mode. If there is a no zero, means there are 0 0, then what you can say? These interrupts are not in pending mode. Okay, and last, to perform serial input of data. समजलं का? हॅलो 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 चैतन्य, रेवती, स्नेहल, यस. व्हॉट अबाउट अदर्स? चैतन्य समजलंय का?
हाँ मैडम.
हाँ मैडम.
Okay. Now, next is a last instruction and last point in our first chapter or first unit. That is a SIM instruction. SIM stands for Set Interrupt Mask. Now see, इथं फक्त आपण इट इज लाईक अ बुक रीड करू शकत होतो की काही चेंजेस करू शकत नव्हतो कंटेंट मध्ये. फक्त हे 1 आहे का 0 आहे त्याच्यानुसार अनालिसिस करू शकत होतो. ओके, म्हणजे काय? इफ दिस बीट इज 1 देन इट इज मीन्स व्हॉट? इंटरप्ट 5.5 मास्क झालाय म्हणजे अवॉइड केला गेलाय सिस्टीम कडून. इफ दिस बीट इज 1, इंटरप्ट 6.6, 6.5 अवॉइड केला गेलाय. इफ दिस बीट 1, व्हॉट वी कॅन से? दॅट इंटरप्ट 6.5 इज in the pending mode. Okay, तसं in the SIM instruction you can change the status, means what? Set interrupt mask. This is a multi-purpose instruction and used to implement the 8085 interrupts 7.5, 6.5 and 5.5 and serial data output. Okay, the instruction interprets the accumulator content as follows. आता ही लाईन अतिशय महत्वाची आहे. आता या लाईनचं मीनिंग काय ते सांगते. See here, to change these bits, see, you do not have any instruction which deals with the SIM. तुम्ही असं कुठलं आहे का मूव बी कॉमा सिम असं आहे का इन्स्ट्रक्शन? नाहीये. मग तुम्ही म्हणजे आपण ठीक आहे सियर पहिल्यांदा आधी बघू की व्हॉट इज दिस मीन आणि नंतर मग तुम्हाला त्या इन्स्ट्रक्शनचा अर्थ सांगते. सी, आता इथल्या सिम इन्स्ट्रक्शन मध्ये यू आर गोइंग टू सेट, तुम्ही सेट किंवा रिसेट करू शकता जे की तुम्ही रिम मध्ये करू शकत नव्हता. ओके, मीन्स व्हॉट? See here, D0, M, these 3 bits are used for the maskable interrupts. If you want to mask the interrupts, what does mean that masking the interrupts? It means you can avoid the interrupts. If you want to avoid interrupts 5.5, what you have to do? You have to make D0 bit as a 1. Okay, जेव्हा आपण हे बीट 1 ला सेट करतो तेव्हा जो इंटरप्ट 5.5 असतो तो काय होतो? मास्क म्हणजे अवॉइड केला जातो. ओके, if interrupt this bit D1 bit should be 1, म्हणजे काय? interrupt 6.5 is masked. Means what? If you want to mask 6.5, you can change this bit to 1. समजते? तसं जर तुम्हाला 7.5 मास्क करायचं असेल तर you have to make this interrupt bit as a 1. Okay, in this instruction, see here, this is a rim instruction. You cannot change, you cannot make it as a 0 or 1. There already should be 0 and 1 depending upon the status. You have to just read that one. Okay, but in the same case you are having the liberty, you are having the chance, you are having that freedom to make it as a 0 and 1. Okay, so if you want to avoid, if you want to cancel for example interrupt 7.5, then you have to make that D2 bit as a 1. Means what? You have to mask that interrupts. Again, what is mean by mask? Maskable means avoidable. Okay, so if you want to avoid this interrupt, you have to make it that bit as a 1. कळतंय का? Now see, MSE. MSE means what? Mask set enable if D3 is equal to 1. म्हणजे काय? हे सगळं कधी वर्किंग करेल? जर हे बिट 1 असेल तर. ओके, मीन्स तुम्हाला या तिन्हीतला कुठल्याही एकाला अवॉइड करायचं असेल तर पहिल्यांदा तुम्हाला एमएससी ला सेट करावं लागेल. ठीक आहे, आता तुम्ही सेट केलं एमएससी D3 bit, you have to make it as a 1. Now you have to decide out of these 3 which interrupts you have to mask. Okay, जर तुम्हाला 7.5 करायचं आहे, then you have to make that bit as a 1. If you want to mask 6.5, then make that bit as a 1. If you want to mask 5.5, then make that bit as a 1. But you have to access these 3 bits. You have to first make D3 bit as a on bit. म्हणजे काय बघा, इट इज अ मेन स्विच. तुम्हाला आता फॉर एक्झाम्पल हे कन्सिडर, तुम्हाला समजायच्या भाषेत सांगते, हा जर D2 कन्सिडर करा फॅनचा स्विच आहे, हा तुमच्या लाईटचा स्विच आहे, आणि हा कन्सिडर करा बेलचा स्विच आहे, किंवा अगेन दुसरं कुठलं एखादं टीव्हीचा स्विच आहे कन्सिडर करा. तुम्हाला टीव्ही लावायचा आहे, तुम्हाला फॅन लावायचा आहे किंवा लाईट लावायचं, तुमचा मेन स्विच काय पाहिजे? तुम्ही सांगा, मेन स्विच काय पाहिजे तुमचा घरातला? If you want to put your fan on, or you have to make your light on, or you have to make on TV, what is the status of your main switch in the home? मीटर पशी जो खटका असतो त्याचा स्विच काय पाहिजे? ऑन पाहिजे का ऑफ पाहिजे? तो
ऑन पाहिजे.
ऑन पाहिजे. म्हणजे काय, मेन स्विच तुमचा जर ऑन असेल तरच तुम्ही टीव्हीचा स्विच ऑन केला तर टीव्ही ऑन होईल, फॅनचा स्विच ऑन केला तर फॅन ऑन होईल, किंवा लाईटचा स्विच ऑन केला तर लाईट ऑन होईल. आता तुम्ही मला सांगा, जर तुमचा मेन स्विच ऑफ आहे आणि तुम्ही फॅन चालू करताय किंवा लाईट चालू करताय, ते चालू म्हणजे ते वर्किंग मध्ये येईल का? येस ऑर नो? येस ऑर नो? तुमचा मेन स्विच घरातला ऑफ आहे आणि तुम्ही फॅन चालू करताय, तुमचा फॅन चालू होईल का?
नाही घेऊ.
नाही होणार. ओके, म्हणजे काय, तुम्हाला यू हॅव टू फर्स्ट पुट युअर मेन स्विच एज टू इन द टर्न ऑन स्टेट. Okay, and then depending upon your requirement, you have to make your fan switch on, light switch on, or TV switch on. Similarly, when you want to mask any interrupt, you have to make MSE mask set enable as a 1. If this bit is 1, then there is a meaning of making D0, D1 and D2 bit as a 1 or 0. Okay, if this D3 bit is 0, then it is no at all going to consider whether it is 1 or 0. मेन स्विच ऑफ आहे, मग तुम्ही फॅनचा स्विच ऑन करा किंवा ऑफ करा, फॅन ऑफ स्टेट मध्येच राहील. समजतंय? तसं एमएसबी until and unless you make MSB bit as a 1, you cannot access these 3 bits. Okay, so whenever you want to mask any interrupts or you want to avoid any interrupts, you have to first make D3 bit as a 1. After making D3, you have to enable masking. Okay, now then you have to decide whether you want to mask interrupt 5.5, or whether you have to mask interrupt 6.5, or whether you have to mask 7.5. Depending upon your requirement, you can make this as a 1 bit, or this you can make this bit as a 0. Okay, is it okay? Is it okay? समजले का? Give me reply. Hello.
Yes, ma'am.
Okay, next D4 bit is a R7.5. If you want to reset, okay, 7.5 interrupts, okay, then you have to make this bit as a 1. So your interrupt 7.5 is going to be reset. D5 is a don't care bit, so it is not going to be used yet, so you have to make it as a 0 whenever you are going to use perform any operation. IDE, it is for the serial data enable, means you have to if you, and SOD is a serial output data. So see here, serial output data means you have to give here serial outputs. But again, when SOD is going to be used, when SDE is on. Okay, it is like main switch for serial operation. Means what? Serial output data, whatever the data you are receiving in the serial output or सिरियल डेटा आउटपुटला जे तुम्हाला डेटा द्यायचा आहे तो कधी रिसीव्ह होईल, जर D6 बिट ऑन असेल तर. समजा D6 इनेबल नाहीये म्हणजे काय, 0 आहे मीन्स डिसेबल आहे, तर व्हॉट एव्हर द डेटा यू आर गिव्हिंग हिअर D7 इट विल नॉट एक्सेप्ट बाय द सिस्टीम. व्हाय? बिकॉज टू मेक SOD on, you have to first make SDE on. Okay, so you have to make SDE, that is serial data enable as on, that is enable, and then you have to go for the SOD bits, that is serial output data. Okay, so see here, what is the use of SIM instruction? Masking and unmasking of RST 7.5, 6.5 and 5.5. Now how you can mask? By using these three bits, D0, D1 and D2. Next, reset RST 7.5 interrupt. So by using D4 you can reset this